Hey guys, welcome to Algebra 1, Section 5.1 through 5.3 test review. Here we go. On this test, we're going to have a whole bunch of vocabulary words, so I'm going to go ahead and go over the definitions and which words they actually match. A horizontal line that a function gets closer and closer to but never intersects. That would be a horizontal asymptote. Letter C. A notation that uses ordered pairs to describe a transformation would be coordinate notation. That's letter G. A type of transformation that shifts the entire graph up or down would be a vertical transformation. So that's letter F. The interest earned at the end of each year is a percent of the principal. So this is the percent of the principal. This is going back to the beginning of the problem and doing a percent of your original investment. That's going to be your simple interest. So that's going to be A. The simplest function of its type is your basic function. That's letter D. The mapping or movement of all the points of a figure in a plane would be transformation. Letter E. The interest earned at the end of each year is a percent of the account balance at the beginning of the year. So this is one where you keep going and you do the percent at the end of the year. So your amount's going to change every month. The percent of the principal, that's your simple interest. That's going to be a linear function because it's increasing by a constant amount, the exact same amount. On this one, we're doing a percent of the account balance at the beginning of the year. So that's going to be your exponential graph. The longer the year goes, or the more years that go by, the more that's going to actually increase. So that's going to be your compound interest. That's letter B. The variable on which the function operates, that is the argument of a function. And what that means, this is I, that means, for instance, here we have f of x plus 3 or f of x plus 3. This operation is happening to the function. It's taking the function and it's raising it 3 units. This operation, 3, is happening on the argument. It's happening on the actual variable. So that's why the variable on which the function operates is the argument of the function. A shift of the entire graph left or right, that would be this example right here. And since it's positive, it's actually going to the left. It's going to the left 3 units. This one is going up 3 units. And that would be your horizontal translation. So that is H. So hopefully you did okay on the vocabulary. You might want to study that for the test because those are 9 easy questions we should not miss. What is the y-intercept of the function f of x equals 0.4 times 3.25 raised to the x? This is an exponential function because the x is in the exponent. So if I want to know what the y-intercept is, I need to plug in a 0 wherever the x is at. So if I go and plug a 0 wherever the x is at, that's 0.4 times 3.25 raised to the x, but instead of raised to the x, it's going to be raised to the 0. If you put this in your calculator, 3.25, you're going to do this first. 3.25 raised to the 0 is actually equal to just 1. So then you're left with 0.4 times 1, which is just 0.4. Remember, when we did this in class, we talked about that number in front of the parentheses. This guy right here, he's actually your y-intercept. You just take this guy and you plug it into the coordinate point 0, 0.4, and that is your y-intercept. Write the function g of x equals 4 raised to the x after a translation 9 units down. So we need to take this graph right here and we need to pull it down by 9 units. So if we're going down, that's going to be a minus 9, and that's going to be an operation that is on the function, not the argument. Anytime you have a translation down or a translation up, that means it's going to be on the function itself. So for this function, it would be g prime of x equals 4 raised to the x and then a big old minus 9 following it. That would be a translation 9 units down. If you were to graph this, 4 to the x would look like this. And then if I pulled it 9 units down, it would go 1, 2, 3, 4, 5, 6, 7, ran out of room, 8, 9. So, and then it would be down there. And that would be the actual 4 raised to the x minus 9. What is the y-intercept of the function f of x equals 3x plus 5? Again, with the y-intercept, everywhere you see an x, you're going to plug in a 0. So that would be f of 0 equals 3 times 0 plus 5. So that just means, this notation over here just means if I plug in a 0 into the function f, what's the output going to be? And the output's going to be 5. Because 3 times 0 equals 0 plus 5, which equals 5. So the y-intercept for this problem is 0, 5. Remember, 3 raised to the 0 would have equaled 1, but 3 times 0 is actually equal to 0. Write the function f of x equals 3x minus 5 after a translation 7 units up. All right, guys, so this one's going to be a little different. We really never did one like this in class. So we have 3x minus 5, and I'm going to take this graph and I'm going to translate it 7 units up. So if I have 3x minus 5, and I want to translate this whole entire function 7 units up, I would add a 7 on the outside of the function. However, I can combine these like terms. This is a minus 5 and this is a positive 7. If I combine those two together, negative 5 plus 7 is actually a positive 2. So my final function would be 3x plus 2. And you could probably write f prime of x out here is equal to that. So this function right here is a translation 7 units up of the original function 3x minus 5. So hopefully that makes sense. Compare f of x equals x minus 3 to the power of 2 plus 5 to the basic function h of x equals x squared. What are the translations on the function? So this is where you got to look at this number right here and this number out here. So if I'm zooming in on just these two numbers, this is tucked in with x. See the parentheses on either side of them? So this operation is happening on the argument. This operation is happening on the whole entire function. This is my left to right shift. This is my up and down shift. So if I have x minus 3, that's actually going to be a shift to the right 3 units. If I have a positive 5 on the outside, that's actually going to be a shift up 5 units. So this one would be a shift up 5 units. So what are the translations? The translation is a shift left, a shift right 3 units because of the negative 3, and a shift up 5 units. Use coordinate notation. Write the function f of x equals x plus 5 as a vertical translation. So remember, coordinate notation is where we'd say x comma y is going to change to x plus a number or y plus a number. Since this is a vertical translation, our x is going to stay the same. Remember, our x-axis runs left and right. Our y-axis runs up and down. So if we're doing a vertical translation, that means your y-axis, or your y coordinates are going to change. So our x are going to stay the same, and our y would change. How much would it change by? Well, look at your equation. It says plus 5. So that means every single y value, I would have to, let's say I had an equation like this, then I would take this dot right here and I would move it up 5 units. So 1, 2, 3, 4, 5. And the new unit would be right there. So I'm taking every single y value and I'm adding 5 to it. So it would simply be y plus 5. And that would be the coordinate notation for that vertical translation. Compare f of x equals b raised to the x minus 8 to the basic function h of x equals bx. And what they're wanting to do, what that part says over here, is just what are the translations. So let's look here. B to the x, that was our basic function. So I have that minus 8. The minus 8 is in the exponent spot. He's tucked in there with x. So he's going to be a shift left or shift right. Because there's a negative sign, it's going to be a shift to the right. So shift to right, and we're going to shift 8 units to the right. What are the translations on the function h of x equals 2 raised to the x plus 4 minus 7? So here we have plus 4, he's in the exponent, he's tucked in there with x, and the minus 7 on the outside. So if I were to rewrite that again, you're probably wondering where the parentheses at. Remember, I've said before, the exponent is understood that there's parentheses all around it. And then here, you've got this minus 7 on the outside. So this 4 is tucked in there with x. I see a positive sign, so that means he's going to go to the left 4 units. This negative 7 is on the outside. He's kind of detached from the function, so this is going to be a shift down 7 units. So what are the translations? The translations are 4 units to the left, and then 7 units down. Okay, let's go to the next one. Which shows the function h of x equals 2x squared after translation 3 units left and 2 units up? This is actually going to be a multiple choice on the test, so you'll have multiple choice answers. But for right now, I should have reworded that. What I want you to do is just rewrite this function after translation 3 units left, 2 units up. That 3 units left. What that means is everywhere you see an x, I need to replace it with an x plus 3. So wherever I see an x in the problem, the x comes out and x plus 3 goes in its place. The reason why it's x plus 3 is because it's 3 units to the left. Whenever we're going to the left, it's actually going to be a plus sign. The 2 units up goes on the outside, and that's just going to be a plus 2 on the very outside. So here I'm going to take x plus 3, I'm going to plug it into x. This positive 2 is going to go on the outside. So that would be h prime of x equals 2 parentheses x plus 3 squared plus 2. And that would be our function after the translations 3 units left, 2 units up. Which, again, which shows the function 7x after translation 2 units to the right. This is a right or left situation, so that's where you have to start those parentheses, the x, and since I'm going to the right, it's going to be a minus sign. So it's going to be x minus 2. And anywhere you see that x, you're going to put in its place parentheses x minus 2. So that would be f prime x equals 7 parentheses x minus 2. And you could leave it just like that. The formula for an account that earns compound interest is p sub t equals p sub 0 times 1 plus r raised to the t, where pt represents the balance in the account after t years, p0 represents the initial amount of the deposit, r represents the interest rate. So that's just telling you what this formula represents. Carrie is considering depositing $2,850 into an account that earns 2.5 compound interest. How much will be in her account after 13 years? So let's break this all down. This is her initial deposit. That's going to be PO. This is her interest rate. That's going to be our R, but before we do the R, we're going to have to make sure that we change that to a decimal. So that decimal would be, if it's 2.5%, carry the decimal place 2 places to the left, and there's our 0.025. And then we have, okay, and that's it. And then the question is, how much will be in her account after 13 years? So that 13 is going to go into the T spot. That's going to be our exponent. So filling everything in, we've got PT equals our initial deposit, $2,850, parentheses, 1 stays 1, 1 plus 0.025, parentheses closed, raised to the 13. So this is where we can go ahead and combine inside of here and put 1.025, and then I'm going to raise 1.025 to the 13th power, and when I do that, 1.378511045. Remember, if you have your calculator, or if you have your cell phone, you could just turn it to the side, and that would give you that exponent spot. Typically, it's the X to the Y button, or it's the Y to the X button, but you would put this number in first, then press that button, and then type in 13. That should get us this lovely looking decimal. If you don't have that calculator, or you don't have that or a cell phone, then you would just take 1.025 and you would multiply it to itself 13 times. That is not the same as 1.025 times 13. It's 1.025 times 1.025 times 1.025, so on and so forth. Okay, now we have to take that lovely decimal and multiply it by 2,850. And when we do that, we get the lovely answer of $3,928.76. This says round to the nearest cent, which means we've got to round to that last number right there. Before I rounded, it was $3,928, and in the change spot we had 0.756. This 6 makes that 5 round up, so that's why it's 76 cents over there. And then we've got, this says dollars, so it would take after 13 years, we would have $3,928.76 in the account. The formula for an account that earns simple interest is PT equals P0, parentheses 1 plus RT. So this is a little bit different because we don't have that exponent spot, so this is a little bit easier to work with. All right, so Gregory deposits $1,200 into an account that earns 2.3% simple interest annually. How much will be in his account after 2 years? So the 2 is going to go into the T spot. The 2.3%, which needs to change to 0.023%, is going to go in the R spot. And our initial deposit of $1,200 is going to go into the P sub 0 spot. So let's go ahead and fill all that in. So PT equals $1,200, parentheses 1 plus R, which is 0.023, times our T, which is 2, parentheses closed. So following order of operations, we look inside the parentheses first. I have to multiply those two numbers. So I would get 0.023 times 2. So that's going to leave me with 1,200 has stayed the same. 1 plus 0.046. I'm going to combine these two and add. 1 plus 0.046 is just 1.046. And I'm going to times that by 1,200. And when I do that, I get $1,255.20. Oh, sorry, that was an ugly. Did it look like that? Ignore that right there. All right, so that's our final answer. All right, what I want to do now with this problem, and I know you don't have this on your review sheet, I want to work a backwards problem with the simple interest. So I'm going to erase all of this work, and I'm going to ask another question on this page. Okay, new question. After how many years will Gregory have $1,338 in his account if it is a simple interest account with a 2.3% interest rate? So here, this is a backwards question because they're actually giving you the $1,338. I forgot to remind you that he had $1,200 in his account. So our initial deposit is still $1,200. So let me cover up that. All right, so if we're going to fill in the actual formula, we've got $1,338. That is our amount in the account after a certain number of years, that's P of T, and that's going to be equal to our initial deposit, which is $1,200, parentheses 1 plus our rate, which is 0.023, and I don't know how many years, so that's going to stay T. So I need to go ahead and solve this equation for T, which means I need to get T by itself. So you have two options. You could, if you wanted, take 1,200 and distribute him into the problem, but I'm not going to do that. I'm going to go ahead and divide him to the other side because there's a multiplication going on between 1,200 and those sets of parentheses, so I'm going to divide both sides by 1,200. So I'm going to do $1,338, and I'm going to divide it by $1,200. And when I do that, I get 1.115 equals 1 plus 0.023 T. And now what I'm going to do is I'm going to subtract 1 from both sides. Don't look at him yet. He's got the variable. You want to move this guy first. So let's go ahead and move him over to the side by subtracting him. And when I do that, on the left-hand side, I'm going to have 0.115 equals 0.023 T. And now what I'm going to do to both sides is I'm going to divide by 0.023 divide by 0.023. And when I do 0.115 divided by 0.023, I get 5, the lovely number 5. So it would take 5 whole years for the $1,200 to reach $1,338. So after how many years? 5 years. The expenses for a company this year were $86,000. The expenses will increase at a rate of 1.8% per year. What will the expenses for this company be 4 years from now? Use the compound interest formula and round to the nearest dollar. So make sure we're rounding to the nearest dollar on this one. Okay, so our $86,000 is going to be our initial deposit or our initial expense. Our rate is going to be 1.8%, and 4 years is going to be our T. So plugging it all into the formula, we've got P of T equals $86,000, parentheses 1 plus 0.018 raised to the 4. So I'm going to combine my like terms first, and I'm going to get 86,000, parentheses 1.018 raised to the 4th power. And now what we do first is we go ahead and we apply that exponent. So that means we're going to do 1.018 times 1.018 times 1.018 times 1.018. Or if you have that calculator that has that scientific button, that exponent button, you just take 1.018, raise it to the 4th, and when you do that, you're going to get 1.0. Sorry, it has a really ugly 86,000. Sorry, guys. Go erase that and start over. You're going to get 86,000, parentheses 1.073967433. I'm going to take that number, I'm going to multiply it by 86,000, and remember we're rounding to the nearest dollar. So when I do that, I get 92,361.1. So that 0.1 does not force that 1 to round up, so our final answer is 92,361. Okay guys, here's the last problem on our review. We've got to make some changes to this problem. First, we need to cross off the graphing because we're not going to graph these functions, and we need to change this 2% to 3.1%. So we're going to have 4% here, and this one's going to be 3.1%. Okay, so here's the table that you're going to be given in the actual equation itself. Oh, let me move this back up, sorry. It goes right there. All right, and I'm actually going to go ahead and give you the formula in the test. So you're going to have both of these formulas given to you, and all you have to do is plug in 0 for t, and then 0 for this t, and fill out each table or each column. And then you're going to compare the answers. Because at the very end, they want you to, into which account would you recommend that Shanice deposit her money? Explain your reasoning. So let's go ahead and let's focus on actually filling out this table and how you would do that. All right, so the very first thing we need to do is plug in a 0 for t. So that's 3,100 plus 124 times 0. Or actually, let's not even do that, because let's think about this. Let's make sense about this. What at year 0, how much money is sitting in the account? That very initial deposit. That's what that y-intercept means. That is the y-intercept when t is 0. So it's our initial deposit, which for both of these is going to be 3,100. All right, now going to 5, I'm going to plug a 5 into here instead. And so what would happen is I would do 124 times 5, which 124 times 5 is, sorry, I thought I had that right here, $620. So that's 3,100 plus $620, which is going to be $3,720. And that amount is going to go up for year number 5. Now to do year number 5 for the exponential, what I would have to do is I'm going to have to plug in a 5 to my exponent. So that's 3,100 parentheses 1.031 raised to the 5th power. So that's where we do 1.031 times 1.031, so on and so forth, until you do that 5 times. And if I do 1.031 to the 5th power, I get the lovely answer of 1.164912556. And now I'm going to multiply that by 3,100. And when I multiply that by 3,100, I get $3,611.23. Okay, so for the rest of the table on down, what you're going to do is you're going to plug a 10 into this spot, and then a 10 into that exponent, and then a 15 and a 15 over here as well, and then a 20 here, the 20 goes here, and then this 20 over here would also go into this spot. So then the 50 would go into this spot, and then the 50 would also go into this spot. So what I'm going to do, instead of wasting the time showing you every single one of those steps, I'm going to go ahead and just fill in the table. Okay, so here's all of the table filled out. Here is your simple interest account, and here is your compound interest account. So what you want to do to be able to answer this final question, into which account would you recommend that Shanice deposit her money, you would need to look at it and see here from 0 to 20 years, that basic savings account actually has, actually not from 0 to 20 years, from 0 to 15 years, it has more money. Right when it goes to 20 years, our compound interest account now has more money than it. So how you would want to answer the question is you would want to say, if it was a short-term investment, if you were only looking for between 0 and 15 years, then you would want to do the simple interest account. If it was a long-term investment, something you were looking to do 20 years from now, then you would want to do the compound interest account. So hopefully this review will help you study for the test that's coming up, and hopefully you guys will do great on it. All right, we'll see you in class soon. Thanks so much for watching. Bye.